I'm Anil Kumar. This is one of the videos on review of application of trigonometric derivatives. Please also go through the links provided here for further details on trigonometric derivatives. We'll discuss 4 questions mentioned here. You can always pause the video, copy these questions, solve, and then look into my suggestions. For your convenience, I've also provided you with derivatives of the trigonometric functions. These derivatives you should remember. You may not be given in test paper. Now let's look into questions one by one. Question number 1. Determine second derivative of y equals to cot 4x. Question 2. Determine the equation of line that is tangent to y equals to 2 tan x, where x equals to pi by 4. 3. Determine all values of x, where x is between 0 to 2 pi, for which slope of the tangent to f of x equals to sin x tan x is 0, horizontal tangent line. Question 4. Calculate object's velocity if position along a straight line is given by s of t equals to sin t over 3 plus cos 2t. And these are the formulas, rather derivatives of trigonometric functions, which are there for your convenience. You need to remember them, right? So that's very important. So let's begin answering them one by one. The very first one is determine second derivative of y cot 4x. Now you know derivative of cot x is what? Now derivative of cot x is actually equals to minus cosecant square x, right? Now some of you may not remember. The idea is that if you do not remember, you can always derive. However, it takes time. Now let us see how much time it takes, right? So let me derive it for you. So when I say y equals to cot x, it really means cos x over sin x. So y dash we'll apply the quotient rule here and write down this as sin square x. Derivative of cos x is minus sin x times sin x minus cos x times derivative of denominator, which is also cos x. So that gives you minus of sin square x minus of cos square x over sin square x. Now this is minus sin square x plus cos square x, which is 1 over sin square x, right? And that is indeed equals to 1, which is negative. This is 1, right? Over sin square x, which is equal to minus cosecant square x, correct? Now, you may not have luxury of doing this in final test or final exam. Therefore, it is good to remember 6 formulas. Is it okay? Now we know that the derivative of cot x is minus cosecant square x. So let's find second derivative of this particular function. So we get dy dx equals to cot 4x. Derivative is minus cosecant square x. So we'll write this as minus cosecant square 4x. Since 4x is the argument, times derivative of inside function, which is 4. Is that clear? So you could write this as minus 4 cosecant square 4x. Now let's find the second derivative, d2y by dx square. Second derivative will be minus 4, 2 times, so we are going to apply the power rule now, 2 times cosecant 4x, right, times derivative of the function, right, times d dx of, let me write, cosecant 4x. Do you get an idea, right? So first apply the power rule and then derivative of inside function. So what you get here is minus 8 cosecant 4x times, now again you have to write derivative of cosecant 4x. So if you don't remember, you may have to, derive this also, correct? So now what I will do is I will just write down the derivative of cosecant x. So what we also know is d dx of cosecant x actually is minus cosecant x times cot x. So what you can see here is that if you don't remember derivatives, then it becomes a real problem, right? So you cannot afford to do all this. So what we get here is, so we are talking about cosecant 4x, inside term is 4x. So let me first multiply by 4, copy all this, which is negative. So, okay, so let's say cosecant x times cot x with a negative sign. So that negative makes this positive. Is that clear? So this negative makes this positive. Okay, I should have written 4x, I'm sorry. The argument is 4x. Okay, so that gives you 32 cosecant square 4x times cot 4x. Is that clear? So that becomes your answer. So what you learn from this exercise is that howsoever simple the question may be, if you don't remember these derivatives, then you may really struggle to answer this paper. Do you understand? So we utilized both these derivatives in one question, right? So when we take up the second question, we'll need the others. Is that clear? Therefore, I'm emphasizing again and again that you need to remember them. I hope that point is absolutely clear. So let's continue and take up the next example. Question number 2 here is, determine the equation of line that is tangent to y equals to 2 tan x. So we are given a function y equals to 2 tan x. We are looking for equation of tangent line at x equals to pi by 4, right? So let's also find y at pi by 4. So y will be equals to 2 times tan of pi by 4, which is equal to 2. And therefore, the point really is pi by 4, 2, right? It is kind of important to know this point since we are looking for equation of tangent line. And you know what equation of tangent line is. It is y minus y1 equals to m times x minus x1. So you need both x and y values. It's a good idea to always find it first. Okay. Now we need slope. So let's find the derivative. So y equals to 2 tan x. I hope you remember derivative of tan x. If not, that is going to be very difficult for your test. Secant square x, right? So that is the derivative. Now let's find derivative at x equals to pi by 4. Now for pi by 4, I can always, draw my triangle. We know if the sides are equal, 1 square root 2 is my triangle for pi by 4, right? Okay. Substituting pi by 4 here, we get the derivative at x equals to pi by 4 equals to 2 times secant square pi by 4. Pi by 4 is square root 2, right? So we get here the derivative as equals to 2 times square root 2 whole square, which is 2. So we get slope as 4. So we know m, slope is 4 at this given point, and the point given to us is pi by 4, 2. Therefore, the equation of tangent line will be y minus 2 equals to 4 times x minus pi by 4. Now let's bring all the terms together. 0 equals to 4x minus y. Now bring this to this side, so we get plus 2. Open this bracket. So 4 and 4 cancel, we get minus pi. Is it okay? So that becomes the equation of line. So we can write 4x minus y plus 2 minus pi equals to 0 as equation of the tangent line at x equals to pi by 4. So I hope that's absolutely clear. So let's move on and solve the other two questions. Question 3. Determine all values of x where x is between 0 to 2 pi, for which the slope of the tangent to f of x equals to sine x tan x is 0. So slope of the tangent is 0. So, well, let's first find the derivative. F of x is sine x tan x. So the derivative of this function is, we'll apply the product rule. So basically, derivative of sine x times tan x plus sine x times d dx of tan x, correct? So we have applied the product rule. So we get cos x times tan x plus sine x times secant square x. You have to remember them, right? There is no option. Let's simplify now. Cos x times sine x over cos x plus sine x times secant is 1 over, or okay, so what we can do here is we can keep secant as such, right? No need to write it as a reciprocal of cos. It doesn't really help. Since what I see here is that cos x cancel out, we have a common factor, so why to worry, right? So I'll keep secant square x as such. Now we can factor sine x, right? This is last minute thinking, which really helps. 1 plus secant square x, correct? So that is what we get. Now the condition is for which slope of the tangent is 0. So slope is 0. So for f dash x equals to 0, this derivative should be 0. That really means that sine x equals to 0 or 1 plus secant square x equals to 0. Now secant square x will be positive, so we have no solution for this one. However, sine x equals to 0 will give us 3 solutions in the given domain, right? So what we have here is, in this domain, which is from 0 to 2 pi, sine function is like this, correct? So these are the 3 zeros. So those are the solutions for you, correct? So we can write down the solution as x equals to 0, pi, and 2 pi, right? That is the solution. So this is 0, this is pi, this is 2 pi for sine function within the given domain. So I hope that is absolutely clear, right? So let's move on and take up question number 4. Calculate object's velocity if position along a straight line is given as s of t equals to sine t over 3 plus cos 2t, right? So what you will observe here is, in 4 examples, I've taken derivatives of all trigonometric functions. We have also reviewed power rule, quotient rule, and product rule. We have discussed solving equations, velocity applications, right? So it gives you a good variety. Now, what is velocity? Velocity is derivative of position, right? So it is derivative. So we'll differentiate this with respect to time. Apply the quotient rule. So we get 3 plus cos 2t whole square. Derivative of sine t is cos t times 3 plus cos 2t minus sine t times derivative of this function, which is minus sine 2t times 2. So times 2, let me write here now. Okay, so that becomes the derivative. We need to calculate object's velocity if position along the straight line is given by this. Okay, so we are given the expression. I think something is missing in this question. We need to find when, right? So that part is actually missing. So let me check that part. I've missed in typing. Okay, but this is the expression for velocity as such. So calculate object velocity at t equals to pi by 4. Okay, so that is the part which was missing. So we'll find velocity at t equals to pi by 4. Okay. So now, since we need to find velocity at t equals to pi by 4, let's use the same triangle, pi by 4 triangle. where the sides are 1, 1, square root 2. So in this expression, let's find velocity at t equals to pi by 4. Is it okay? So we can actually directly substitute the values and find the answer. Let me simplify it a bit. Anyway, we'll do it along substituting the value. Okay, so we have cos of pi by 4 times 3 plus cos of 2 times pi by 4 means pi by 2 minus. Minus and minus becomes positive, 2 we write here. Then we have sine pi by 4 times sine, this becomes pi by 2. Does it make sense to you? Divided by 3 plus cos pi by 2 whole square, right? So that is the expression. Okay, now what is cos pi by 2? Cos pi by 2 is actually equals to 0, and sine pi by 2 is equal to 1, correct? So we'll substitute these values and find our answer. Sine and cos pi by 4, cos pi by 4 equals to sine pi by 4, which is equals to 1 over square root 2, correct? So these values are 1 over square root 2 within bracket 3 plus, that is 0, plus 2 times 1 over square root 2, and this is 1, okay, divided by 3 plus 0 whole square. Now this gives you, now we have square root 2 in the denominator, 3 plus 2 is 5, so we get 5 over square root 2 in this part, right? So this part here, the numerator, is 5 over square root 2 times, the denominator here is 3 squared, so 1 over 3 squared is 9. Perfect. So that is the answer we get, 5 over 9 square root 2. So that is the exact value. The answer could be written in decimals, 5 divided by, within brackets, 9 square root 2 equals to 0.39, let us say. Okay. The units normally will be, let's write meters per second for the time being. Normally we'll assume that displacement s of t is in meters and time is in seconds. Is that okay? So that is our answer. So we write velocity at t equals to pi by 4 is equals to 0.39 meters per second. Is that okay? So that is the last question of this sequence. I hope you learned the method of solving such questions. Most important part here is to remember the derivatives of all the trigonometric functions, as that may waste a lot of your time if you start deriving them in final exam, right? So back to our first sheet, remember these, it's very critical. Thanks for watching and all the best.